Tonight we're going to continue our discussion of dilations. Tonight's objective is I can use a scale factor to dilate a figure and determine the properties preserved. Let's take a look at this first example. Find the coordinates of the image of the figure shown to the right after a dilation centered at the origin with a scale factor of 1/2. So the first thing I need to do is I need to figure out what our original coordinates are. So the coordinates of this point are 4, 8. This point is 6, 6. This point is 2, 6. And this point here is 4, 2. So now I'm going to take each of those points. I'll start with my 4, 8. I'm going to multiply each of my coordinates, each x coordinate and each y coordinate by 1/2. And that will give me the coordinates of each point on my new figure. So what's 4 times 1/2? Well, half of 4 is 2. What's 8 times 1/2? Half of 8 is 4. So I know 2, 4 will be the coordinates of one of my vertices on my new figure. Let's take a look at 2, 6. If we're given a scale factor of 1/2, you're going to multiply each coordinate by 1/2. What's half of 2? Is 1. What's half of 6? 3. 6, 6. Again, as soon as you know your scale factor is 1/2, you're just multiplying each x coordinate and each y coordinate by 1/2. Half of 6 is 3. Half of 6 is 3. And finally, if I have 4, 2, and I multiply each of those coordinates by 1/2, half of 4 is 2, half of 2 is 1, and I'm ready to plot my new figure. So the first coordinate is 2, 4. They ask us to find the coordinates of our new figure, so 2, 4, 1, 3, 3, 3, and finally 2, 1. Now I don't have a ruler. You're going to use a ruler. Then you just go ahead and connect each of your new vertices. You're going to notice our new shape is still a kite. Still looks just like the kite, except it's shrunk down. It's half as large. So that's how we find the image of our original kite after a dilation centered at the origin with a scale factor of 2. That's it. We're done with that problem. Now let's talk about the properties preserved. The dilation to the right shows rectangle EFGH and its image, which is rectangle E prime, F prime, G prime, H prime, after a dilation with a scale factor of 1/2. What do you notice is preserved? What hasn't changed? Well, let's take a look. If I look here and I look at angle EFG, this angle here, you're going to notice that angle is 90 degrees. On the image, angle E prime, F prime, G prime, hey, that angle is still 90 degrees. Does that work for each of the angles? Let's check. How about our original EHG? Hey, that angle is 90 degrees there. How about our image? E prime, H prime, G prime. Hey, that angle there you can see is still a right angle. That's still 90 degrees. So what's preserved? What hasn't changed? Angle measures. So angle measure is preserved. The angles still map to congruent angles. Well, let's see. It used to be that side length was preserved. Let's see if side length is preserved. F to G is 1, 2, 3, 4 units. So let's hope F prime to G prime is also 4 units. Oh no, F prime to G prime is 1, 2 units. All right, side length is not preserved, which means perimeter won't be preserved. If we look at area, area is not preserved. So what else is preserved besides angle measure? Oh, maybe we could consider orientation. F to G to H to E. Here, in our image, F prime to G prime to H prime to E prime. Oh, good, orientation is preserved. Miss Pearson, if we're talking about Dilations, angle measures are preserved, orientation is preserved. What is the third item preserved for dilations? I'm gonna be honest.
Not perimeter.
Nope.
Oh,
Parallelism. Oh, ladies and gentlemen, parallelism is preserved. What that means, you're welcome. What that means is FG is parallel to EH on the original. So FG is parallel to EH on the original figure. And if you look at our image, if you look at F prime, G prime, F prime, G prime is actually parallel to E prime, H prime. E prime, H prime. For a minute, I have to tell you, I couldn't even remember what was preserved, but parallelism definitely is. That means if two lines are parallel to each other in the original figure, in the image after a dilation, those two line segments will still be parallel to one another. Oh, good. There you have it. Now let's talk about what doesn't stay the same. First of all, let's figure out the perimeter of our original rectangle. Well, FG, we talked before, is 4 units. GH is 1, 2, 3, 4, 5, 6 units. HE is 1, 2, 3, 4 units, of course. This is a rectangle, so I know E to F will also be 6 units. So for our perimeter of rectangle EFGH is 4 plus 6 plus 4 plus 6. So that's going to get us 10 plus 10 is 20. So that's 20 units. Let's check the perimeter of our image. F prime to G prime is 2 units. G prime to H prime is 1, 2, 3 units. So E prime to H prime is 2 units, and E prime to F prime is 3 units. So to find the perimeter of our image, that's going to be 2 plus 3 plus 2 plus 3. That's actually going to be 10. Hey, so if our scale factor was 1/2, our perimeter of our image is actually half the perimeter of the original. That's pretty neat. Let's see if that happens with the area. Well, to find area, we do length times width. We figured out the length of the original was 4, the width of the original was 6. 4 times 6 is 24. So the area of our original rectangle is 24 square units. Let's look at the area of our image. Length times width, 2 times 3. 2 times 3 is 6. Wow, for the area, it's not half the original. It's actually 1/4 the original. So for the area, if the scale factor is 1/2, then the area will be 1/4 the original size. Oops, sorry, didn't mean to end the show. Let's go to last viewed. Sorry about that. All right, so now we know that the area does not remain the same. The perimeter does not remain the same. So if we look at the rectangle EFGH and its image, E prime, F prime, G prime, H prime, what are the differences between the two figures? Well, the perimeters will be different, and the areas will be different. Something else that's different, we talked on the last slide, is actually the side lengths. FG was 4, F prime, G prime was 2, so the side lengths will change. And that is what will not be preserved in a dilation, or what changes when we handle a dilation. The perimeter will change, the area will change, the side lengths will change. All right, try to have a good night. Take care.